Okay, just looking at exponential equations where you've got something to a power. So to solve exponential equations, just like any equations, you use inverse operations. The inverse operation of square is square root. The inverse operation of cube is cube root. The inverse operation of square root is to take the square. Remember, for squares, take the square root, it's plus or minus square root. Okay? And for cube roots, the inverse operation of a cube root is a cube. For example, here, we're not going to write these ones down. We'll do some in the exercises. X squared is 9. Remember, x equals plus or minus the square root of 9. All right? If we had like this, 5n cubed is 40. You'd divide by 5. So you'd get n cubed is, sorry, is that square? Yeah, cubed is 8. So you would take the cube root. So they're doing cube root of both sides. But obviously cubed root and cube cancel, and you can just show it on this right-hand side. That n would be the cubed root of 8. Okay? In this next one, if you're trying to solve something like this, okay, because you can't really write 4 to the power of 2/3. Like you could write, like 4 is 2 squared, but that's all you could write. So what we do with these ones, see, if you multiply 2/3 by 3 over 2, you get 1. So what you do for this type of question, you take, instead of squaring both sides or look, you could even take the power of 6 of both sides if you wanted, but you'd end up with 4 to the power of 6. So if you did 4, if you took power of 6 of both sides, or power of 3 actually, if you took power of 3 on both sides, do you know why I might do power of 3 on both sides if I wanted? Because a squared is 64. So that's the way to get rid of the 2/3. But you can even go lower than that. You don't have to take cubes of both sides. You could take the power of 3 over 2 of both sides. Because 4 to the power of 3 over 2 is the square root of 4 cubed. And then that way you solve a directly. But you could take cubes of both sides. So when we do some examples, we'll do it both ways. All right? All right. Now, with these types, 3 to the power of x is 81. You would just write your 81 with base 3. 81 is 3 to the power of 4, so x is 4. We will do some questions in a minute. With this one, I think we did some of these earlier, did we? 5 to the power of 2k minus 1 is 25. You'd write your 25 as 5 squared. And then you equate your indice bits. We're going to be doing some of these, all right? And this one here, a to the power of n is 4. We did work like this. You'd write them both with base 2. Okay, and we will do ones like this. So that's your critical step, writing 8 as 2 cubed, 4 as 2 squared. So they're both base 2s, and then you just equate the powers. Okay, so we're going to do some questions like these. So exercise 3.6, exponential equations. We're just going to do a couple from the exercise. More than a couple, but so let's start. What have we got? 6n squared is 92 plus 4, it's 96. N squared is 96 divided by 6, which is that 16? And so therefore n is plus or minus the square root of 16. Don't forget to take plus or minus, please, which means that n is plus or minus 4. So with squared, inverse operation of squared is plus or minus square root. Okay? All good? 3q cubed, negative 4 minus 20, that's negative 24. What's q cubed? Negative 24 divided by 3, which is negative 8. So is q going to be positive or negative? Because a negative times a negative times a negative is a negative. Look, watching. Negative times negative times negative is a negative. So q is the cubed root of negative 8, which happens to be negative 2. It's negative 2. So for cubes, no plus or minus, all right? But powers of 4, you could have plus or minus every time you've got even powers. Except, yeah. All right, next one. 3a to the power of 2/7 minus 2 equals 10. So what are we going to do first? Take the 2 over. Take the 2 over and divide by 3. So we've got 3a to the 2/7 equals plus 2, that would be 12. A to the power of 2/7 is 12 divided by 3 is 4. Now, look, we could do both sides to the power of 7 if we want, but you end up with a squared. So what we're going to do is take both sides to the power of 7 over 2. Why? Because 2 over 7 times 7 over 2 is what? 1. So 4 to the power of 2, 7 over 2. That's better. So I've got A equals, now 7 over 2, the 2 underneath, that's the square root. That's to the power of half. So that's square root of 4 to the power of 7. Square root of 4 is 2 to the power of 7. Yeah, 128. Okay. Look, the other thing was if you take both sides to the power of 7, you're going to end up with 4 to the power of 7. And then you've got to square root that anyway. All right. All right, the next one. Do the same thing. 2 to the power of 3/4 equals what? 9 times 3? 27. No, it's 9 times 3. Inverse operation of divide by 3 is to times by 3. Okay, we're going to take both sides to the power of 4 over 3. And that is a good idea because you can do the cubed root of 27, you see. So we get that t equals the cubed root of 27 to the power of 4. What's the cubed root of 27? 3. So it's 3 to the power of 4, which is 81. Because it's 3 squared times 3 squared. 9 times 9 is 81. So 4i, x to the power of negative 2 is 2 1/4. We've got a few options. We could write 1 over x squared because x over negative 2 is 1 over x squared, or we can leave it like this for now. Let's just see. X to the negative 2 is 9 over 4. But isn't 9 over 4 3 over 2 all squared? So x over negative 2, that's 3 over 2 squared. Are we okay with that? All right. So there's a few ways we could do this. If I want x squared, wouldn't it be the reciprocal of this? Why don't I write, look, x to the negative 2 is 1 over x squared. How about that? Is 3 over 2 squared. Are we okay with that? Good with that? Flip both sides. You can fraction equals fraction, flip both sides, x squared equals 2 over 3 squared. So 1 over x squared is 3 over 2 squared. X squared, flip both sides, turn them both upside down. You'll get x squared over 1 is 2 over 3 squared, which is 4/9. Oh, we're trying to solve for x, aren't we? So actually just look at it. If x squared is 2 over 3 squared, can you see, you can directly already see what x is. X has to be 2/3. Okay, you can compare. The squares are the same, so the x must equal 2/3. Okay. No, do here. This actually is plus or minus because this is x squared equals 4 over 9. X would be plus or minus the square root of 4 over 9, which is plus or minus 2/3. So you've got to be careful with that. If it's x squared, it's always plus or minus. Okay. Okay, the next one. So I'm going to write that as 1 over b to the power of 4 is, they can be written as powers of 4. I think it's the same. 2 over 3 to the power of 4. So what are we going to do? Flip both sides. B to the power of 4 is 3 on 2 to the power of 4. Now, remember that 3 over 2 to the power of 4 really is 81 over 16. So b, because b to the power of 4 is b squared times b squared, you could have, look, watching, a negative times a negative times a negative times a negative will give you a positive. So it is plus or minus the 3 over 2. Okay? We okay with that? So it's plus or minus the 4th root of 81 over 16. It is plus or minus 3 over 2. Because a negative, watching, a negative times a negative times a negative times a negative is a positive. Question 5i. You can, do you want to write this as 1 over b to the power of 5 over 3 equals 1 over 32? How do you feel about that?
That's good.
What do you think would be the obvious natural thing to do next? Flip. Flip both sides. So b to the power of 5 over 3 equals 32. What do you think we should do now? Take both sides to the power of? To what? The 3/5? And isn't, so therefore, we've got that b equals the 5th root of 32 cubed. Isn't the 5th root of 32 2? 2 cubed is 8. All right, so similar to the other one, just with the negative indices. All good? Try this one on your own. I would be writing this m to the negative 2/3 if you want as 1 over m. 1 over m to the 2 cubed. What are you going to do with 36 and 49? It's got to be 6 over 7 squared. What should we do next? We don't want 1 over m to the 2 cubed. 2 over 3. So we're going to flip both sides. M to the power of 2/3 equals what? 7 over 6 squared. Then we're going to undo the power of 2/3 by taking what powers of both sides? 3 over 2 equals 7 over 6 squared. 7 over 6 squared to the power of 3 over 2. Yeah? So what have we got on the left? M equals, what's 2 times 3 over 2? 3. So it's 7 cubed over 6 cubed. 6 cubed is 216. 343 over 216 or 250. Yeah. Divide by 5, so 3 to the power of x is 45 divided by 5, which is 9. So therefore, we know that 3 to the power of x is 3 squared, so therefore x is 2. Okay, keep going. Next one's fine, easy. Keep going. 18 times 2. So those are easy. Sorry, I didn't realise the 2 were going to be the same. Of course, you would never do 6 divided by 2 because the 6 is to the power of k, but the 2 is not to the power of k. If the 2 was also to the power of k, you could do 6 divided by 2, but it's not. And also with this one, not to multiply the 5 by the 3. Okay? That's why I chose those two. Okay, next one. 2 to the power of 4x equals 256. Can we write 256 as a power of 2? Yes, 256 is 2 to the power of 8, so that one's easy. Equating powers. So this one's fine. So we've got x is 2. Question 7J. 9 is just 9 to the power of 1, so you can just equate indices. 3a plus 1 is 1. So what have we got? What does 3a equal, girls? 0. So therefore a is 0. And that makes sense because 0 plus 1, 9 to the power of 1 equals 9 to the power of 1. Okay, have a go at 8i. What do you think you want to do? You need the same bases, so you need to change this 4 into what? 2 squared to the power of 3k equals 2. Look, you could write that as 2 to the power of negative 2 if you want, because 1 over 2 squared is 2 to the power of negative 2 to the power of 3k. Do you know why I'm doing this? Because I want to be able to have both base 2's on the left and the right hand side. So 2 to the power, look, you don't have to do it this way, but I think it's a good idea because now what do you do with the negative 2 and the 3k? 2 to the negative 6k equals 2 to the 1. Now you can equate powers, yeah? And you get that negative 6k equals 1, so k is negative 1/6. Now, if you want, if you did try this some other way, you'd have 1 over 2 to the power of 6k. So if you would have gone 1 to the power of 3k and 2 times 3k, you'd end up with the 6k down here. You'd have 1 over 2 to the power of 6k, which is 2 to the negative 6k, 2 to the power of negative 6k as well. Do you see why we've done this? It brings the 2's back onto the numerator. I don't want a 2 on the denominator. Okay? All right. Now, J, writing them both with base 2. So 2 cubed to the power of x minus 1 equals 2 squared. All good? What do we do now? 2 to the power of 3x minus 3 equals 2 squared. So 3x minus 3 equals 2. 3x is 5. X is 5 over 3. Keep going. 3. 3 cubed to the power of x plus 3 equals 3 to the power of x. 3 to the power of 3x plus 9 is 3 to the power of x. And then you can now equate your indices and you'll get, all good? 2x is negative 9. X is negative 9 on 2. And keep going. Do you want to, you can either flip both sides, because 1 to the power of anything is 1. Unless it's 0 actually. Oh no, that still is 1. Even 1 to the power of 0. Or we can just flip both sides, because this is 1 to the x over 2 to the x equals 1 to the 2x plus 3 over 64 to the power of 2x plus 3. I'm flipping both sides. So 2 over 1 to the power of x equals 64 over 1 to the power of 2x plus 3. I don't need the 1's, do you see? I don't need the 1's. So 2 to the power of x equals 64. Isn't that 2 to the power of 6? To the power of 2x plus 3. So 2 to the power of x equals 2 to the power of 12x plus 18. And now we can equate powers. So x is 12x plus 18. What did you get? 11x is negative 18. Yeah? Is that what we got? So therefore x is negative 18 over 11. Power of negative x. Now this is 1 over 5 squared, which is what? 5 to the negative 2. See? 1 over 25 is 1 over 5 squared, which is 5 to the power of negative 2. Okay? So 5 to the negative 2, x minus 9. So 5 to the power of negative x equals 5 to the power of negative 2x what? Plus 18. So now equating powers, negative x equals negative 2x plus 18. And you get x is 18. All right, keep going. 10i. 81 is, well, it's 9 times 9, which is 3 squared times 3 squared. It's 3 to the power of 4, bracket, x plus 1, equals, how are you going to write this? 3x to the power of a half. Square root is power of a half. Multiplying your indices, you know, a to the m plus times a to the m to the power of n is a to the m times n. So we've got 3 to the power of 4x plus 4 equals 3 to the power of x over 2. Equating indices, 4x plus 4 is x over 2. What would you do next? Multiply both sides by 2, and you would get 8x plus 8 is x. So you're multiplying through by 2. And so now you've just got 7x is negative 8. X is negative 8 over 7. Yes? And keep going. So J, we've got 5 squared to the power of negative m equals. We're going to write 1 over 5 as 5 to the negative 1. 3m minus 5. So multiplying 5 to the power of negative 2m equals 5 to the power of what? Negative 3m plus 5. Equating powers, negative 2m equals negative 3m plus 5. Taking over to the left, m is 5. And the last one, C. How are you going to write? So you can do one step at a time because you don't want to mess this up. What's the square root of 2? Square root of 2 is 2 to the half. Just write it as 1 over 2 to the half first. So on the next line you can bring it up. Is what? 2 squared bracket 4x minus 5. Oh, 2x, sorry, minus 5. Now how am I going to write 1 over 2 to the half? 2 to the negative a half equals, now I can expand, 2 to the power of 4x minus 10. And now we can equate our powers. Negative a half equals 4x minus 10. You can multiply through by 2. I probably would. Negative 1 equals 8x minus 20. So multiply through by 2. And what have we got now? 8x is what? 19. 8x, negative 1 plus 20 is 19. So x is 19 over 8. Isn't it?